Okay, this is lesson um, three. Today, what I am going to draw about is math. I think I wanted to start out with lines, and the purpose of this is to show you that artists and people use maths all the time. So anyways, we already use it. We can identify one thing, two things. It basically, math is just defining relationships. So we can say, if this is the same as that, well, they're equal. Or if we have more on one side, well, math, you can just write it out. We have more of those on one side of the other one. Where am I going with this? I think what I'd want to say is that we already use it. So looking at proportion, for instance, we can see like this sort of shape, and in our mind, and kind of roughly we can sort of see that these two things are scaled. So that's basically it. Like, what I want to get across is that math is actually basically writing out the logical ways that we think. It's writing out a relationship that basically says this is that, only bigger, right? It's like twice the size, maybe. So yeah, I'm not doing as much drawing as I thought I would be doing, which this was actually the point, was to draw things. So, for example, counting, math. What I wanted to say is that without math, without this, we wouldn't have the tools that we have now to do art. We wouldn't have paint, because color sort of is math. You can actually sort of measure color. We do this using red, green, and blue for computers. And the reason that we do that is because our eye has like 3 sets of cones. One of these sees red, one sees green, one sees blue, and I think we got rods in there too that sort of measure intensity of color, like brightness, light and dark. But we can measure this and record it onto a device, and then have that spit out an image, right? We can do that, and that is because of math. I think what I wanted to talk about was basically turning like real world objects, like I should have one. I have like a pen, but that's kind of boring. Something simple, like a cylinder, like this, right? My pencil sharpener. So from the side, it's kind of like that. From the top, you can see further in the camera that it's a circle. And from the side, we sort of get this weird blobby shape made out of nubs. right? Yeah, that's terrible. So one thing that we do is use perspective, but I don't think people realize that perspective was developed through mathematics. It was developed through having an observer looking through a projection plane, which is actually our piece of paper or our medium, and looking at like a tree, right? So we see the tops of this tree, and on our paper we kind of draw the outline of that, and people realize that by doing that we can sort of put onto a piece of paper the things that we see with our eye. So like if we have fence posts like this, right? But we're looking at it over here, we kind of get these weird angles where on our piece of paper, this one and this one, they look further apart than this one, right? So like we get our sort of perspective, right? And there's all kinds of tricks to this, but that's just, you know, math. You don't even need numbers for this, right? Math isn't about numbers. It's about grouping things, and a lot of it's really simple, like counting. That gives you a number, but it doesn't need to be that way. We can sort of draw triangles and look at geometry, and we can ask questions like if I draw something twice as big as this, by that I mean this is like 2 of those, and this side is like 2 of these. Does that mean that this is going to be 2 of these? I think in our head we kind of know that and think that that's how it's going to be, but we can sort of show that, right? Because if this is our triangle and this is B, we can also say that, you know, that's the same, and this is the same, and this is the same as that. So that means that this is the same as that, and this is the same as that. And that's math. What I don't know. It's I think what the problem is that you have these people that don't understand that math is actually, you know, basically describing the logical ways that we think, right? It's like grouping things together. We can like group this and this. We can say that 2 groups of 3 gives you 6, and you know, that's sort of all it is. It's not really all that tricky. What happens is that, oh my god, what happens is that at some point we see things like this. I don't know what goes there. We start seeing things like this, and we go, well, where the hell did that come from? And what does that even mean, right? Like, I don't know. There's something that you do in high school where b plus or minus something over whatever gives you x. And yeah, why? Like, how did we get there? I think that's sort of the trouble, because this is actually built up of a lot of little steps, a lot of little triangles that actually, if you sort of group everything together, let's say we have squares, will sort of turn into that, right? And then we use this relationship for other things. Yeah. It's not, I don't know. It's not really, it's not a big deal, right? There's a lot of simple steps to get to where you want to go. And you know, the trick is just sort of seeing the same thing like in a slightly different way. And it's yeah. So how is this going to help you draw? I think is the question. Well, for one thing, you can actually measure. Like, if you have a reference, you can measure this distance and then, you know, multiply it by some number and then get like your scale doodad. But yeah, I don't think I'm talking about this quite the way I want to, because like what I want to say is that you don't need to worry about it, but thinking about it, thinking that shapes have within them some sort of relationship, it's kind of neat, you know. We can say that there's a relationship between this line here and that circle, that sort of loop. I'm not going to tell you what that relationship is because it's pi. But sort of realizing this, you can draw all sorts of shapes, right? I'm sort of going over my time limit, but like a line, that's sort of like a mathematical thing, and the instructions to get to a line are start here, go straight to another point, right? That's easy. That's fun. We draw lines all the time. You can a circle. How do you get a circle? Well, we have tools that, like, if we have a string here, we can trace around that point, right? So it's just sort of this relationship. And if we have this circle, kind of looking at it from its side, like we have a circle, looking at its side, we can sort of see it has that elliptical shape. If we kind of extend that, we get a cylinder, like a pen, right? And then you can get all sorts of shapes if you like cut this open so that we have a thing with a little slice in it, and then at the other end we're gonna have the rest of this, right? So just looking at like ordinary shapes and ordinary lines can give you like all these marvelous things, all these weird curves, all these weird shapes, and we can use what we know about light and lines and color to draw like really amazing things. Yeah, I went too long because I was kind of excited about this, but if you're interested, I highly recommend a book called Measurement by nope, that's not it, by Paul Lockhart. This is actually one of the few books I have read most of. I got about 2/3 of the way through, but it's super interesting. Yeah, I'm sorry I didn't draw more. I'll draw more next time. I apologize.